Also, if we have to calculate the efficiency of this engine, how can we calculate efficiency? Okay, I'll write it here. Efficiency is what? Total work done by the engine or the working substance upon the heat taken, heat absorbed. So what is work done? This is Q1 minus Q2, there Q1 minus Q2 upon total intake of heat. So this comes out to be 1 minus Q2 upon Q1, right? This is equal to efficiency. Now look at this formula, that how can the efficiency of this engine be 100%? Efficiency will be equal to 1 or 100% when Q2 is equal to 0. That means the total heat which was absorbed from the source is converted into work done, and there is zero heat, no heat is supplied to sink. That means there is no leftover heat. What happened? Total heat got converted into work done, no wastage. So Q2 in practical use, Q2 can never be equal to 0 because there will always be some part of heat which will be supplied to sink, and that is why Q2 will have a non-zero value, and according to this equation the efficiency can never be 100%. So basically the term efficiency is actually, this efficiency is fundamentally governed by a independent law of nature which is known as second law of thermodynamics, which we are going to discuss in our next topic. So second law of thermodynamics explains this part, that efficiency of an engine can never be 100%. That's the basic module. One more thing, what type of heat engines have we been studying? Basically there are two type of heat engines, one is external combustion engine and another is internal combustion engine. So in external combustion engine, which is called ECE, external combustion engine, in ECE the combustion of or the combustion chamber is actually outside the main engine body, whereas the other part is internal combustion engine, where the ignition takes place. Internal combustion means ignition or the combustion takes place inside the main body of the engine chamber, right? So there it is outside the main chamber, here it is inside the main chamber. The examples are the previous type of engine like steam engines. They are two-stroke engines. Once the combustion is taking place and then the piston movement is taking place. So that was two-stroke engine like steam engine, and then internal combustion engines are like petrol engines and diesel engines, which are four-stroke engines where the combustion of the working substance takes place inside the chamber, where in first part I've told you it's four-stroke engine. In first part the inlet pipe opens and the fuel is injected in. The second part, inlet valve closes and it is ignited. Then the third step, combustion takes place and it pushes the piston, and in four steps the exhaust pipe valve is open and exhaust takes place. So this way these are two-stroke and four-stroke, or external combustion and internal combustion engine are basically two types of heat engine.